Alright, Muggles, this is how the magic happens. This is the circuit board I designed. The red traces are the top layer, the red traces are top layer, the blue traces are the bottom layer. It's going to be a double layered board. So I designed it using this program. And here's what I'm starting with. It's just a double-sided board with fiberglass in the middle, copper on both sides. So just to make this custom circuit board, I did all the software program tricks, got everything set up and ready. Here is my CNC machine, which is ready to fire up for the first part. So I already did a auto leveling session and it's ready to start. So let me go ahead and find the start button. Oh wait, before I start, obviously I gotta turn the CNC head on. Come on. A little too fast. Should be at 10,500 RPMs is where I want it. That's not enough. .4, that's close enough. I got a 1mm bit on there, and it's going to be done in 3 different steps. So I'm going to go ahead and click start button here. So it's just going to drill out, I don't know, about 30 holes. But it's going to be 3 different steps. I've got a whole set of 1mm holes. And then I've got a set of 0.4mm holes that are the vias. And then the 3rd step is going to be cutting out the board outline. And what a via is just a way of connecting the one side of the board to the other side of the board electrically. And so I got to do that in a different step because that requires me changing the drill bit. So it's just going to drill out all the 1mm holes. And once I have the holes drilled and the circuit board cut out, I'll come back and we will start working on chemically etching the traces onto the circuit board. Alright, well that step finished, so let's take it out of here, see what it looks like. So the next step will be to chemically etch the traces. all I did was vacuum it off and remove the bit. I got tape stuck to me. Alright. So you can see all the holes it drilled. Luckily I set the depth right so it went all the way through. So it leaves like 4 little tabs that you can just pop it apart. So if I hold this up to the light, yeah, there's quite a few holes. There's at least 30 or so. So next step will be chemically etching the traces. Well, actually chemically etching off everything except for the traces. I just think if you had to drill all those holes by hand and they have to be in perfect alignment, you'd never do that. That's why I got the CNC machine. So alright, I'll be back with showing the next step, which is the chemical etching. Alright guys, so I took a laser printer and I printed out the traces onto a piece of magazine paper for each side, and here's the board. So it's just like any other iron-on. I got my iron warmed up. I'm going to lay these papers on the way they're supposed to go, and then I'm going to iron them on and transfer the laser printer toner onto the copper. And then when we chemically etch it, it'll eat away everything except where the toner is covering, and that's how we make the traces. But I'm going to need 2 hands for this part, so I'm not going to record this part. I'll record when we're etching the board later. Alright, so I got the toner transferred onto the copper, and it turned out good, as you can see. So that's just the laser printer toner on the spots that I want to keep. So I'm going to throw this into here. Let me zoom in a little bit if I can. And I'm going to put some gloves on, and I'm going to mix the acid and start the chemical etching process. It requires 2 parts hydrogen peroxide and 1 part muriatic acid. So I'm just going to do a half of one of these cups as 1 part. So a full cup of hydrogen peroxide. And then a half a cup of muriatic acid. Alright, and now you're going to start see it turning green. And the green is the copper that it's etching away. By the time we're done, this will be pretty green. So I'm just going to sit here and agitate it just a little bit and flip it every once in a while, and it should be done in about 3 minutes. And you'll see it as it's as it's finishing in certain areas before others. So I'm just going to do this for a minute or two, and then I'm going to flip it and do this to the other side for a minute or two. And then it'll probably start to be getting close. You'll see the edges start disappearing first. Let me go ahead and give it a flip. I'll just keep agitating it. Now it's starting to turn pretty green. It's the copper etching away. So now you can see the edge. The edge is starting to become clear. Alright, I'm going to flip it again. So I got this copper clad circuit board. I get sheets of it off of eBay. This one is like super thick compared to the rest of them for some reason. The copper layers are the same, but the fiberglass in the middle is thicker than usual. Flip it again. It's almost there. Just gotta get that last little bit of copper. And once it's done, I'm going to use acetone and a what do you call that? Scotch Brite pad, and that will remove the toner from the copper that's underneath it. So all them lines that are still there covered in black toner are still going to have copper underneath them. Just got this one little spot here. Let's give it a flip. Take a closer look. I think it's done. Yep, it looks done. Alright, I'm going to go ahead and stop the video, get cleaned up, and then I'm going to take the acetone and a Scotch Brite pad. I'm going to expose what we got left as far as copper traces go. Alright, there's the finished circuit board. I got the toner cleaned off, and it turned out pretty great. Holes lined up pretty good. It's always hard to get everything to line up exactly perfect when you do it two-sided, one from scratch. But it turned out pretty good, really. So if I turn it over, this side's got a lot less on it. And this side's got a whole bunch on it. So alright, I'm going to start soldering it together, and then I'll be back. Alright, so there it is, soldered together. It's a real pain to do all the vias, which are these right here, them two, a bunch over here. So I'm waiting on one piece to come in the mail that goes here. It's like a big square thing, and So each one of these is a stepper motor driver, and here's the stepper motor. I can control this to real precise turn, and it takes 4 wires. So each one of these is a stepper motor driver. Each one of these runs one of these motors. So they each got 4 wires each. These two are for the lasers. Oh, I forgot to tell you that I'm making a 3D laser scanner. So laser scanner to make 3D models. So here's one of the lasers. It just makes a red laser line, not just a dot but a whole line. And they have 2 wires. So when I have 2 lasers, there's the 2 hookups for the lasers. All these are extra. I'm not really focusing here. Well, I learned the hard way to... Here, let me zoom out. Maybe that's the problem. I learned the hard way to put extras in just in case you forget something. Alright, let's see if it'll focus better now. Either way, yeah, I'm waiting on parts. I'm waiting on this one part, which is the power buck converter. And I'm waiting on to set the laser scanner up a little more, so I got an idea how long to make the wires. So I'm not going to solder anything on until I know how long to make the wires and all that. But so yeah, there's the circuit board. Start to pretty much finish. I mean, those are the main. Oh, and that's just a microcontroller that I can program, and this will actually hook to a laptop and control the turntable and control the up and down of the laser scanner. And then it'll transfer that information through USB cord to the laptop to a program I'm going to write that's going to process the pictures and turn them into a 3D point cloud, which then gets turned into a 3D model, which then can be 3D printed. So there's the circuit board. And I got her mostly done. Alright, we're going to end the video.